Alright, in this lesson is going to be on inverses and square root functions. We've talked about square roots, but we haven't talked about square root functions. Well, an inverse is when you do the opposite operation, which you already know is the opposite of adding is subtracting, opposite of multiplication is division. So the inverse of squaring a number is square rooting a number. So we're going to look at square root functions today. We've been looking at quadratic functions, functions that match this format, x squared plus something. Okay, so we're going to be looking at square root functions. Okay, so if we want to find an inverse is a function that undoes another function. So what happens graphically is all the x and the y values get flip-flopped. So the x's become the y's become the x's. That's true on an inverse function. So the steps to find an inverse would be to switch the x and the y variables, and then you solve that new equation for y, and you'll get the inverse function. So let's look at this first example. We've got f of x equals x plus 4 over 2. Well, f of x, this means the exact same thing as y. So you could actually write this as y equals x plus 4 over 2. These mean the exact same thing. Okay? Now, we could switch this into a different form, but let's graph this by using the old-fashioned plug in some points. So let me just plug in some points here that might work out nice. Let's say if I plug in 0 for x, 0 plus 4 is 4 divided by 2 is 2. So when you plug in a 0 for x, you get 2 as a result. Okay? Now let me plug in another point, maybe plug in a 2. If I do 2 plus 4, you get 6 divided by 2 is 3. So now we've got 2 points. We can graph those points. So here's the point 0, 1, 2. And then we can plot the point 2, 1, 2, 1, 2, 3. And if we'd like to make this a little easier to graph, we could use the slope between these 2 points, which is up 1 over 2. So if we go up another 1 and over another 2, we get another point, up 1 over 2. We got some points here. Okay. So this is the graph of that original function. So this function takes a 0 when you plug it in and turns it into a 2. It takes a 2, you plug it in, it turns into a 3. Well, an inverse function should work the reverse of that. If we plug in a 2 into this inverse function that we're going to find, you should get a 2. If we plug a 3 into it, you should get a 2. So, to find the inverse, we're going to start by switching x and y. So we're going to make that y an x. And we're going to make that x a y. And we're going to write everything else identical to what we started with. Okay? Now we need to solve for y. So we need to bring these values to the other side of the equation. So we start by, since we have division here, we have to undo that with multiplication. So I'm going to multiply each side by 2. So the 2 comes over to this side. You get 2x equals, this side just leaves you with a y plus 4. Now I need to subtract the 4 over. So 2x minus 4 equals y. So this function here is your inverse. Okay. Now if that truly is the inverse, if I make my table of values here, and I take these y values and make them my x values, then these x values should end up being my y values. Let's see if that happens. Plug the 2 in here. This is 2 times 2, which is 4, minus 4 is 0. Plug the 3 in here. 2 times 3 is 6, minus 4 is 2. And if you notice, these tables are just reversed. Okay? So this truly is the function that undoes what this function did. So now let's plot these points. Let's plot the point 2, 0, and then the point 3, 1, 2. And if we look here at our slope, it's up 2 over 1. So we go up 2 over 1, up 2 over 1. So here is the graph of our inverse. So this was our x plus 4 over 2. And this is our 2x minus 4. Okay. Now, I'm going to graph one more line here. I'm going to graph the line y equals x. And y equals x where the x and y values are identical. So here's the point 0, 0. This is the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. If I draw in this perfect diagonal line, again, this is a line where y equals x, you'll notice that these are mirror images of each other. This distance here is the same as the distance there. This distance here, same distance there. And that's true over on this side as well. They're mirror images of each other. Okay? That happens on an inverse. Okay? In the second example, we're going to look at finding the inverse of a quadratic. This was a linear problem, like you would have done in Algebra 1. The next one we're going to do is going to be from Algebra 2.